Well, here we go. Factoring a trinomial when a is 1. Okay, now we have standard trinomial form would be ax squared plus bx plus c. All right, so a is the coefficient of x squared, and when a is 1, we can factor it using what we call the product and sums method. It's actually kind of fun. All right, so we're going to factor the following trinomials, and then we'll check with multiplication. So we see it, it's a trinomial. A is 1, that means that the number in front of x squared is 1. So what we do is we just call this the x, okay? So we take c, which is the last number, and we take b, which is the middle or the coefficient of x, and we put that down here. So this is going to be my sum, this is going to be my product. And we find two numbers that multiply to 4 and add to 5. So they multiply to 4 and add to 5. And those two numbers are 4 and 1, both positive. And once we have those two numbers, we are now going to write these three terms as a factored trinomial, which means that we're going to have a binomial times a binomial. And so the first one's x squared is x times x. So that, let's put that in a little highlight. This x squared will be here and here. And then let's go with the purple. And so then now we look at this 4 and this 1, and that's where we're going to put right here. So it doesn't matter if you put the 4 here and the 1 here because I don't have signs in. The last thing I want to put in are my signs, and since 4 plus 1 are both positive, so I need a positive 4 and a positive 1. And so my answer is x plus 4 times x plus 1. I'll hit that in blue. So this is my factored answer, and then I'm going to check it by multiplying it out. So we have x times x, x times 1, 4 times x, and 4 times 1. And then if we combine these two terms in the middle, we get what we started with, x squared plus 5x plus 4. And that is the trinomial that we started with. Okay, now there are real good reasons to have these trinomials written in factored form, and you'll find that out at the end of this chapter or later on. Okay, so here we go. Let's try this guy. We've got x squared plus 7x plus 12. So, by the way, these are examples where the signs of both the middle term and the final term, the b and the c, are both positive. All right, so let's go with 12 is our product, 7 is our sum. Okay, now we do have a lot of numbers that times to 12. It could be 1 times 12, 2 times 6, 3 times 4, but only one of those are going to add to a 7. Aha, it's 3 and 4. So once I get those, then all I have to do is put my parentheses, put my x's in front because the x times x gives me my x squared. And then I take the two numbers that multiply to 12, 3 times 4, and add to 7. They're both positive. So that's, whoops, let's take this one. This is my answer. And you can check that with multiplication, x times x, 4 times x, 3 times x, and 3 times 4. And then combine your 3 and 4, and you get the trinomial you started with. Check. Ching. Okay, so here's the summary for this. If the signs are both positive, then so will the signs in the factors, okay? So when you factor, you will also have two positives. Okay, we're going to do a few of these so you'll get the hang of it. Let's go here. I am going to move this. Let's go to down a little bit there. All right, let's try that. Okay, so this time we're going to do some, yes, these are rigged. All my videos are pretty much rigged to give you patterns. This time the middle sign is negative. We have a trinomial. We're going to factor this trinomial. Only this time, even though we still have a as 1 in front of x squared, this time we have the middle sign is negative. So let's put our positive 3 up here, our negative 4 below. Now we need to find two numbers that times to 3. Well, it's only 3 and 1. And that would be 3 times 1. And they better give me a negative 4. Otherwise, we're going to have to call this trinomial prime. So we have, well, sure enough, if I make it a negative 3 plus a negative 1, then a negative times a negative is a positive 3, and a negative 3 plus. Sure enough, they work. So once I have that, I'm going to take this and make it thinner. There we go. Okay, once I have that, then I can get my parentheses, and I put my x's in the front. And then I put my -3 and my -1 basically in the middle. So when I multiply this out, I have x squared minus 1x minus 3x and then a plus 3. And so if I put that together, I have x squared minus 4x plus 3, and that's my check. So the answer is, in factored form, x plus x minus 3 times x minus 1. All right, let's try another one. I like the green, but not quite so thin. Let's go with this side. Okay, so first of all, I'll make my x. Positive 12 is the product, and negative 7 is the sum. I have, again, 1 times 12, 2 times 6, or 3 times 4. Only one of those will give me a negative 7. Not always the case, all right? You got to be careful. Well, it is always the case if it's negative 7. All right, so I've got these two. And if I put a negative on the 3 and a negative on the 4, they will multiply to a positive 12 and they will add to a negative 7. So that is cool. So now I can go with parentheses, x is in the front, my -3 minus 4, and then double check it. So I get x squared minus 4x minus 3x and a plus 12. It's important that these match up. Otherwise, it's not factored correctly. Okay? All right, so the summary here is, if the middle sign is negative, then this is kind of nice to have. If the middle sign is negative and the last sign is positive, okay, I can put that on there. It's also the last sign positive. You got to have both of these. Then that's, I'm talking about this right here. Let's see. If this middle sign is negative and this last sign is positive, then you will be guaranteed to have two negatives in your factors. Okay, so I'm going to go back up to this one. If both signs are positive in your trinomial, that means this positive and this positive, then these will definitely both be positive. If the first one's negative, the middle sign's negative, and the C term is positive, then you will have two negatives. All right, now we have this one again. This is the same. Well, this one's going to be, the last sign is negative, but the middle sign is positive. So so this one was middle sign is negative, only the last sign is negative. Then that's going to be another little pattern. Okay, so let's take our 5, minus 5 up here, positive 4. So it's only 1 times 5. There's only two numbers that times to 5. But the question is, I need a sign on one of those because it needs to be a positive 4 when I add them. So it's either going to be -1 plus 5 or 1 plus -5. And I need a positive 4, so we're going to stick with this one. All right, so let's go ahead and factor it. We'll put our x's in the front to get our x squared, our 5 times 1, and then we decided we would put the negative on the 1 and the positive on the 5. Okay, and we can check that out, and we will get the same trinomial. Okay, let's do the same. Let's see, we got our x's here. Oh, this time we have a negative. Let me just do a little bit nicer x here. Spread, there we go. We have a -12 in the product and a 4. What? They add to 4. Let's see, we've got 1 times 12, 2 times 6, and 3 times 4. Do you see it? I see it. It's right here. If I use a 2 and a 6, then I'll say 6 take away 2 gives me a positive 4. And 6 times negative 2 gives me a negative 12. And that is going to work. So let's go with x times x, and we had our 6 and 2, and we decided we'd put the minus on the 2 and the positive on the 6. And then we'll double check that, and it works. Okay, so if the only the last sign is negative, then you are going to have either a plus and a minus, or a minus and a plus. And you've got to figure out which one is positive and which one is negative so that you get your middle term when you multiply them. Okay? All right, we have one more case, and that is both signs are negative. Both signs are negative. Okay. All right, so let's go ahead and do our -5, -4. So they're both negative. I know I have to start with 1 times 5. Okay, so I've got to use a 1 and a 5. But what am I going to do with those? Is it going to be 1 take away 5 or 5 take away 1? Which one gives me the -4? And in this case, I want the larger number to be negative. So when I add them up, I end up with a negative. Okay, so we'll put x in front. I put my 5 and my 1, but in this case, the negative must be on the 5. Positive on the 1, so when you multiply that out, it works. Let's try this one, -12, -4. All right, so I've got my 1 times 12, 3 times 4. I know it's 6 times 2. The question is, which one of those is going to be negative? Well, if this one's negative, then it's the larger one. Okay, so I've got my x times x, my 6 times 2, and because this is negative right here in the middle, my -6, my +2 checks. So when both signs are negative, you're going to have a plus and a negative, but the negative is going to go on the larger. I can just put larger. Okay. And up here, if the last sign is negative, then the negative, you can trial and error, but really it's going to go on the smaller. Okay. Some people like to memorize rules that way, and some people just like to work it out and times it, which is great. Okay, so we're going to keep going here, and I want you to know that the first thing you do, if you remember the first trick, was to factor common factors. So the first thing you're going to do, no matter what, no matter where you are, where you are at, you're going to pull out the common factor. So they all have 2. So first I pull out 2. And then I look at what's left, the trinomial inside only, cover up that 2. Just look at just the trinomial inside now, right here, and see if we can factor that. Okay, so I've got them to multiply to 5 and add to 4. Well, I know it's got to be 1 times 5, but how am I going to get 1 and 5? It's got to be 1's got to be negative. It's got to be 5 minus 1 is 4, and that won't work because 5 times -1 is not. This will not work because it's not going to work. I need a +5 and a +4, and if they're both positive, both of my factors are positive, and that is not going to work. So this is as far as I can take my answer. This is factored completely right here. The inside trinomial would be considered prime, but I did get a factor of 2 out. All right. All right, let's try another one. Oh, look, the first term is negative, so I'm going to take out -2, and I'm left with x squared plus 7x plus 12. And now I'm going to look and see if I can factor that inside trinomial with a 12 and a 7. And if they're both plus, so are these. And sure enough, it works. So I've got a plus plus, which means I have x times x, 3 times 4, plus plus, completely factored, yes. By the way, we can always multiply these out to check them. All right, let's go with the last one. They all have a 3, leaving us with x squared plus 9x plus 8. Again, I'm in a plus plus mode here. That's real nice because they're going to have a 8 times 1. Let's see, I've got 8 times 1 or 2 times 4, and they have to add to 9. So there we go, 8 times 1. And if these two are plus in my trinomial, then when I factor it with a 8 times 1, so are those. Again, I am completely factored. There's my answer. Okay. So don't forget the first step, take out the common. Would you like to pause the video and factor these? Please do so now. I'm going to be doing them quickly right now. So this time I have to take out a 2 and an x before I can factor. And then I'm going to say, oh, they must multiply to -5 and add to -4. Well, that's got to be 5 times 1. But one of them has to be negative. And if the bottom one's negative, the larger one's negative. So I'm going to keep my 2x in the front. I'm going to have 3 factors here. I have a 2x, and then I have these two, 5 times 1, -5 plus 1. There's my answer right there. Okay, let's try this one. Oh, they all have a 5. X squared minus 4x minus 12. Well, 12 can either be 1 times 12, 6 times 2, or 3 times 4. I'm going with the 6 and the 2, right? It's -12 and -4. So which one's negative? The largest one. So I'm left with the 5, x times x, 6 times 2, and negative and positive. So there we go. All right, and we'll try the last one. Looks like they all have an x. Let's pull that common factor out so I get a perfect standard form trinomial that I can factor. All right, so 8 can be 1 times 8 or 2 times 4, and I need a 2. So, whoops, come back here. So I'm going to get my 2 times 4. Let's see, I'll make my x right here. It's got to multiply to -8, add to -2, so that means the 4's got to be negative. So I have 3 factors again. And we've got a 4 times 2. The 4 is negative, the 2 is positive. And again, if I wanted to, I could multiply those up and see that indeed they do work. Okay. Here's 3 more if you'd like to pause the video. Okay, hopefully you paused the video, and if you needed time to do these are just stranger ones, so I'm going to try these. Okay, they all have a 3, and I'm left with x squared minus 11x plus, let's see, 3 goes into there, 116. Is that correct? Okay, 4, yes. Okay, now we've got multiply to 16, add to -11. I've got 8 and 3, 4 and 4, 1 and 16. I'm going with the 8 and the 3 because since one's positive on top, they're both going to be negative. So we'll take the x minus 8 and the x minus 3. Okay, there we go. And let's go with this. Okay, they all have a 3. Let's pull that out. X to the third minus 5x squared plus 6. Well, it looks awfully good, but guess what? We don't have this rule for x to the third. What we're doing right now is only works for a standard trinomial where a is 1. Well, a isn't even, this is our a. A standard trinomial is ax squared plus bx plus c. There's no x cubed in it. So this answer right here is my final answer right there. Can't go any further. Okay, on this one, oh, pull out the x squared. Yeah, and that leaves us with a standard trinomial. Let's see, I got 22x and 120. Now, did we figure that out? What am I going to, oh my gosh, all the numbers that times to 120? Way too many. Oh my gosh, there are so many numbers. 5 goes in there, 6 goes in there, 7, 8, 9, 10. Oh my gosh, let's see. 6 times 20, 5 times 20 something. Regardless, I found it. I found it. It's 10 and come back here. It's 10 and 12 right there. So I'm going to keep my x squared out front. This was a stumper. I meant it to be a stumper, just so you know they're not all nice and rigged. If I put a 10 here and a 12 here, since it's a positive on the end, yes, we go. We've got a positive here and a negative here. So we want the numbers to multiply to a positive 120 and add to a negative 22. So my 10 and my 12 will both be negative. Yes, there we go. And we are looking at a factored trinomial, which, woof, look at that. It started with a 4th power. No wonder it was weird. This one started with a 3rd power. No wonder it was weird. So watch out for those if they aren't perfectly standard form when we start. Okay, that's the end of this video. You could try to factor trinomials where a is 1 right now. That would be a great thing to do.